Hello and welcome back to Higher Maths, Logarithms and Exponentials. We're going to look at exponentials. First of all, we're going to look at the graph of y equals a to the power x. Okay, so y equals a to the power x is a curve that goes through the point 0, 1 and also through the point 1, comma a. So if we take, for example, y equals 2 to the power x, so y is the y coordinate, x is the x coordinate, anywhere on this curve. So if I looked at the values of x of -1, 0, 1, 2, 3 and calculate the corresponding y coordinates, so that would be 2 to the power -1, just substituting in x as -1 here, which is 1 over 2, which is a half, 2 to the 0, anything to the power 0 is 1, then we've got 2 to the power 1, 2 squared, 2 to the power 2, 2 squared is 4, 2 cubed is 8. So the coordinates on that curve will be -1, comma a half, 0, comma 1, which is this point here, no matter what the value of a is, 1, comma 2, which would be this point here if it was y equals 2 to the power x. I've got 2, comma 4, 3, comma 8. So what's going to happen here, this is just going to increase and increase and increase and increase and get very, very steep very, very quickly. Right, if our value of a is between 0 and 1, so for example y equals 1/2 to the power x, we could do a similar table of values and we'll just find out that if we've got a value between 0 and 1 for a, rather than increasing, rather than growth occurring, decay is going to happen. So it's going to drop and drop and drop. It's going to get closer and closer to 0 but never actually reach 0. Okay, so if you've got your notes in front of you because you've been absent or you're doing some catch up, so a to the 0 is always 1 and anything to the power 1 is itself, so a to the power 1 is a. So it's always going through the point 0, 1 and 1, comma a. Even if a is between 0 and 1, this point would be 1, comma 1/2 if we're doing 1/2 to the power x. Okay, so that's a little bit about the exponential graphs. So exponentials and the constant e. The constant e is a very important number in maths, just like pi is. We're all aware of pi being 3.1412, etc. We've obviously it links to the circle, pi times diameter for circumference, pi r squared for area. Also links to spheres and cones. Okay, so the constant e is just another very important mathematical number. And the value of e is roughly to 9 decimal places is 2.718281828. So we do have that on our calculator. So if we've got a lovely shiny Casio calculator, here it is, shift ln button. Okay, so shift ln and there's e to the power. So if I wanted to work out e squared or e cubed, I'd just be putting the 2 or the 3 in there. But if I do e to the power 1, which is just e, there's the 2.718281828. Okay, where does that come from? It just comes from basically substituting in larger and larger and larger and larger values in here for n. So it could substitute in 100, and which I've just done, and it comes out as 2.70. And then it just gets closer and closer to this the more and more you increase n. Okay, so what we really need to be able to do is to use this. We need to use e. So question 1, just evaluate e squared. So literally on the calculator, we're only just pressing buttons here. So second function, shift ln to get e squared, press equals 7.389 to 3 decimal places. 5e to the -1.2, so 5, shift ln to the power -1.2. There we go, 1.506 to 3 decimal places. Straightforward enough. So number 2, and a question for yourselves. So a van hire company calculates the depreciation and the value of its vans using this formula, where V0 represents the initial value. A new van costs £18,000, calculate its value after 5 years. So I've got V0, the initial amount, that's 18,000, so I can substitute that in. I want the value after 5 years, so rather than writing v of t, which is the value after any time, V of 5 is the value after 5 years, so that's just the notation we're using. So V of 5 is e to the negative 0.16. Why am I using that? Because it's in the formula here, multiplied by the time, multiplied by 5. So I'll just type all that into the calculator, and as it's money, I would round to 2 decimal places. So that's that one done. So you guys have got a similar question here about the population of rats. So rather than V bracket T here, P subscript T just means the same thing. So P subscript 2 is just the population after 2 weeks. Okay, so if you guys want to pause the video and have a go at that question. Okay, so I'm assuming you've either unpaused it now or you just didn't bother doing that. So we'll just go through the question quickly. So again, we've got this formula. We want to know the population after 2 weeks. We know the initial population is 500, so just substituting in those values, evaluate it on the calculator. Population after 7 weeks, P subscript 7. So 500 e to the 0.132 multiplied by 7, which is 1,260 rats. Okay. And guys, now you've watched that, go and try these questions here. So full written solutions are available on the Madras Maths page in the higher revision materials section. Okay. So there's full written solutions, which I've done for all of these questions. There's also just the answers that should be in the back of the textbook, but the company that produced the textbooks didn't add them in for some reason. Okay, so try those questions and check. Again, written solutions are ideal, so you can go through line by line. You can see where you're making a mistake if you are making a mistake. Or you can just check with the answers, and assuming they're all correct, that'll be fine as well. But if you do get them wrong, make sure you correct them by looking at my solutions.